Classification trees is the topic of today. We're going to talk about the single trees, traditional tree-based models. Then we're going to talk about the difference between the traditional models and the random forest. And at the end, the last but not least, the XGBoost, a gradient boosting model that won a lot of competitions on the Kaggle, and it's kind of like the king of the models. Yeah, let's go. Now, the data that I'm using is the default data from the Introduction to Statistical Learning. You can download that data from the free of charge from the website of the Introduction to Statistical Learning. And what I'm doing here, I'm not gonna do any feature engineering, I'm not gonna do any data exploration and so on, because I already did that, and today's topic is not about that, so I'm gonna go straight forward to the topic of today. I'm mapping yes and no of the student to 1 and 0, and the same I'm doing with the default, so I have everything numerical. As you see, we have only two continuous data. The other is the categorical. I'm seeing the correlation, and there is some negative correlation, positive correlation, and so on. And then I'm importing my data. My packages. I will need to split the data to train and test data. I will need the decision tree classifier and the plot the tree to see how that they are partitioned, and from the sklearn ensemble, because random forest is an ensemble model, we are gonna get the random forest classifier, and at the end we are gonna get the XGBoost. As a final step, we're gonna see the accuracy of all these models to compare how they are working. We're splitting the data. Like random state is 111. It can be differently made, but it doesn't change anything. So we can use it 42 for being more compliant with the existing literature. And here we are using the decision trees for on the decision tree, by the way, since it's a randomly taken the different forests, as it's known from the name random forest, we need to indicate the random state too in this. So what we are going to do here, we are fitting the training data set with the of the training data set of X with the training data set with Y. So it's gonna be our default values. The default what's the default here, and what we are doing here, we are getting that default of the train and fitting that, and then we're predicting with the test set of the X, and as a result we are getting the accuracy of 97. All right. What else? We have here these leaves of the tree. As you see, it seems like leaves of the tree, and if you move to the top of the tree, you're gonna see that we have the origin of the tree that's starting from the very top of the tree. Actually, that was the very top. Sorry, I just lost it. It's gonna be in the middle. So it starts with the balance is under and below to this number. So then it goes true on the left and false on the right. It continues until the Gini in here, Gini impurity, is gonna be 0. Gino 0, and it finishes over there. The last one is balance is this, and then if true, a Gini is 0. That means that in that probabilistic repartition, we have a 0 on the class yes, and and the one on the class no, and the same here, the 7 on one class. So it's pure. There's no impurity of the leaf. That's why it stops here. As you see, the model is so huge, and it tends to overfit usually on the training data sets. We are not gonna see the overfitting concept today, but usually it overfits. That's why what we are using the random forest. So for the random forest, we are getting the random classifier that we have imported before, and then we are fitting the X train and Y train. Then we are getting the predictor for the random forest. So as you see, the random forest result is 96 to either, and as well as this one is 96. So there's not a lot of differences between the results of this and the tree-based model. Let me see if there's a result if we are not gonna round it. This one is 96.5, and meanwhile this one is the traditional tree is 956. Or we'll see it soon, just in a second. Right. By the way, I'm gonna make this library, not library, the working sheet available on the my GitHub account. I'm gonna leave on the commands my GitHub. It's 957.965. So there is a difference if we are not gonna round it. So there's improvement on the testing data, right? And the last one is the gradient boosting. Again, here we need to eliminate this part in order to see whether there is the difference between the random forest and the gradient boosting. Gradient boosting actually there has the specificity of the penalizing the data. Actually, it's penalizing the models and trying to improve the model. With this one, as you see that the random forest predicts better. There might be different reasons of why. For example, the number of the features are not. There should be the different partition of the number of features, the ratio of the features and the observations, the number of the observation and so on. Everything impacts on the results of the model. Usually XGB classifier works very good with the huge data sets. So this is the introduction to the tree-based models. We have seen the classification models, tree-based models, and we have concluded with the random forest, which is the ensemble model, and the last one is the boosting model, extreme gradient boost and XGBoost. Hope it was useful. See you next time.